Okay, so putting it all together, adding and subtracting the rational expressions with unlike denominators. Keep in mind, these have the potential to become very long, very tedious problems. You want to start at the top of the piece of paper, at a minimum the halfway point. Some of these will take a lot of room. So factor the denominator and find the least common denominator is going to be our first step. The factoring, depending on how comfortable you are with factoring the trinomials, you may want to do on the side. So you want to think a little bit about how to organize your paper. And you build up each rational expression to have the LCD as its denominator as our second step. And this is where things start looking worse rather than better. But then once we do have the common denominator, then we can add or subtract the numerators and keep the common denominator for our last step. And then, I don't think I put this in as step 4 because you don't always do it. Sometimes you can reduce your rational expression. That doesn't always happen. But take a look at, you've done the adding, subtracting, combining like terms, and see whether or not it will reduce afterwards. Okay, these first two shouldn't be too bad. The first one, the least common denominator, with the 4 and the 6, looks like 12. 2 times 2, 2 times 3. So least common denominator would be the 12, and then we'd need the x cubed, the x with the larger exponent. So let me just make a note here on this side, LCD, 12x to the third. And then I need to rewrite each of these terms to have the 12x cubed as its denominator. So I've got the 1 over 4x cubed, and then I'm going to multiply by 3, supposed to turn red, there we go, 3 over 3 to get the 12x cubed. And then I've got 3 over 6x squared. Now to make it a 12x cubed, I'm going to need a 2 to get a 12, and another x to get an x cubed. And I can do that to the denominator as long as I also do the same thing to the numerator. So that gives me 3 over 12x cubed plus 6x over 12x cubed. Now resist the impulse to start reducing fractions. I know we've done a lot of reducing of the fractions, and it's tempting to want to do that, but if we do start reducing fractions at this point, we won't have a common denominator. So I want to go ahead, add the numerator, 3 plus 6x over 12x cubed. We've simplified it. We now have a single rational expression, but we do want to check and see if we can reduce it all. So we can factor a 3 out of the numerator. And a 3 out of the denominator. Those 3's can cancel, leaving us with 1 plus 2x over 4x cubed. We cannot reduce between the 2x and the 4x cubed because the 2x is a term. And we can't cancel terms, we can only cancel factors. It's only if we can factor something out of the entire numerator and out of the entire denominator, like we did here, that we can do the reducing. Okay, next example. I think the LCD is going to take just a little more work because we need to factor the denominator here. So sometimes I just do these in line with the problem if the factoring is fairly simple. Then I've got a square subtract a square. So this is when I do enough. I know that's x subtract 2 over x plus 2. And then I've got 3 over x plus 2. So my LCD I think is fairly obvious. I'm going to need the x plus 2. But I only need it in here once because it doesn't show up more than once in any one denominator. And then I'll also need the x subtract 2. Okay, so this is nice. The first rational expression here already has the LCD as its denominator, so I don't need to do anything to modify this one. So only the second term in this rational expression needs to be modified. I've got the x plus 2, I'm missing the x subtract 2, so I'm going to multiply this one top and bottom by x subtract 2. And now I've got 2x over my LCD plus 3x subtract 6 over my LCD. Okay, so now that I've got the common denominator here, I can go ahead and add the numerators. Get a little more room here to work. So adding the numerators, I'll have 2x plus 3x subtract 6 all over the common denominator. And then I can combine like terms here. 2x plus 3x is 5x subtract 6 over x subtract 2, x plus 2. And there's nothing I can factor out of the 5x subtract 6, so it doesn't reduce. That is my final answer. Okay, got a couple more down here. This one again, a little bit tricky because it's almost the same factor in the two denominators, but with the x plus 2, x subtract 2, my LCD is going to be x plus 2, x subtract 2. Let's see, get a little room here. There we go. Okay, so LCD on this one, x plus 2, x subtract 2. And so this one's missing the x subtract 2, this one's missing the x plus 2. So when I set these up to do the addition, I'll need to multiply this one by x subtract 2 over x subtract 2. And I'll have to be careful with subtraction. Very easy to lose a sign in there. And then my missing factor on this one is x plus 2, x plus 2. And so this one's, again, I hope you left plenty of room on your paper for this one. Let's see. So distributing here, I have 4x squared, subtract 8x, 4x times x, 4x times the 2. And this is over my x plus 2, x subtract 2. And then I'm going to be subtracting. So this will need to FOIL out. X times x is x squared. X times 2 is 2x. Negative 5 times x is negative 5x. Negative 5 times positive 2 is subtract 10. All over my LCD. I'll just swap the order here. X plus 2, x subtract 2. Multiplication's commutative, so I can change the order of either of these. And I only change the order to make it obvious then that I've got the same order as over here. So I've got that common denominator. Let's see, so I've got a bit of a mess to clean up here. I do have some like terms here I can combine. And then what I want to be very, very careful here is that all of this is being subtracted, and this subtraction is going to need to simplify or distribute through these parentheses all the way through this second rational expression. So rewriting, because again I've got the common denominator now. I've got 4x squared, subtract 8x, and then I've got to subtract x squared. The 2x subtract 5x is a negative 5x. But I'm subtracting that negative, 2x subtract 5x is negative 3x. I'm subtracting the negative 3x, so I get a plus 3x here. And then I'm subtracting the subtract 10, so I get a plus 10 here, all over my LCD of x plus 2, x subtract 2. So I've got some like terms. 4x squared subtract x squared is 3x squared. negative x plus 3x is to subtract 5x, and then I've got a plus 10 all over x plus 2, x subtract 2. And I'm pretty sure that I am done. I'm going to take just a moment and think a little bit about whether or not this will factor up in my numerator. 3 times 10 is 30. Factors of 30 would be 1 and 30, 2 and 15, 3 and 10. I'm not thinking of anything that's going to have a sum of negative 5 here. So I believe I've got that one done. Okay, so coming to this one here, I've got b over 4 subtract 2b, and a b subtract 2. So I'm thinking I'm going to want to factor a negative 2 out of here to see if I can get a b subtract 2 to match this second denominator. So let's see, I've got b. If I factor a negative 2 out of here, that'll leave me with a negative 2. Negative 2 times negative 2 is a positive 4, and a plus b. Okay, and negative 2 plus b is the same thing as b subtract 2. Let's go ahead and write it that way, b subtract 2. So now I can see my least common denominator will be the b subtract 2 and the negative 2. And again, my first expression here already has the LCD as its denominator, so I don't need to change it. The second term here needs the extra negative 2. This subtract 2 does not cover this particular factor because this one is a term, whereas this one is a factor. It's joined by multiplication. This one's joined by subtraction. Okay, switch over there to red. So I'm going to take this and multiply by a negative 2 and multiply by a negative 2. Better put a sign in there, otherwise it looks like I'm subtracting 2. Okay, so I've got b over negative 2, b subtract 2, subtract. Let's see, distributing here, negative 2 times b is negative 2b. Negative 2 times negative 1 is a plus 2. In the denominator, I can just leave it in factored form. And then I've got to be careful that I'm subtracting here, so all these signs are going to switch back a second time. And I'm going to have b plus 2b subtract 2 all over my negative 2 times b subtract 2. And let's see, combining like terms in the numerator, b plus 2b is 3b over negative 2, b subtract 2. Okay, and again, it might be tempting to try to cancel this subtract 2 with this subtract 2, but we can't because they're terms. And this negative 2 here is a factor, but it cannot cancel with this subtract 2 because this is a term. Okay, let's do just one more here. And one thing I wanted to show you that you might find useful or might not is if you've got a lot of factoring, sometimes to make your problem flow better, you might find it useful. You can draw a line on the side of your page, come over to the side, you have a little working space here. So we could do the factoring on the side. Let's see, looks like this will have to be a subtract 1 and a subtract 1. That way the negative 1 and negative 1 multiply for a plus 1, but add to a negative 2. And then our second denominator there, x squared subtract 3x plus 2. Factoring that, let's see, x squared would have to be x times x. 2 would have to be 1 and 2. And if both the signs are negative, then they multiply to the positive 2 and add up to the negative 3. And then I can come over here and just write my factored form. So you might find that helpful. You may not need to do that. Okay, so our LCD, we've got x subtract 1s, and we've got x subtract 2s. In the first expression, there is an x subtract 1 times an x subtract 1. It's showing up twice there. So I will need the x subtract 1 twice in the LCD. It's either x subtract 1 times x subtract 1 or the shorthand notation with the exponent of 2. And then I also need an x subtract 2. There's one of those in the second term. So when I build up my fractions to have that common denominator, this one, the first one, is missing the x subtract 2, and the second one is missing this second x subtract 1. So those will be the missing factors I need to multiply in. So here we've got the 3, the x subtract 1 squared that we already had, and then I'm building up with an x subtract 2 over an x subtract 2 plus the 1, x subtract 1, x subtract 2 that was already there, and then multiply in an extra x subtract 1 and x subtract 1. Whoops. Let's go away. There we go. So that I've got the x subtract 1 squared. Okay, so now got a common denominator. So I've got a 3x subtract 6, distributing through my numerator here, plus 1 times x for x, and 1 times subtract 1 for subtract 1, all over x subtract 1 squared over x subtract 2. And again, your choice, if you prefer to write this as x subtract 1, that's fine. This is just a little shorter. Okay, a little more room here. And then combining like terms, I've got a 4x subtract 7 over x subtract 1 squared, x subtract 2. And I am done because there's nothing I can factor out of 4x and 7. They have no common factors. Okay. You want to try this next one on your own? I'll pause a minute. So how'd you do? This one a little more complicated with the 3 terms, but same principles. Factor each of the denominators, and the x squared subtract 5x factor to the x times x subtract 5. And then our LCD, we need the x and the x subtract 5. So the first term was missing the extra x, so you multiply it by x over x. The second term, second rational expression, already had the LCD as its denominator, so we didn't have to mess with that. And then the third one needed the x subtract 5, which we need, again, we have to put in both the numerator and denominator, because what we're doing really is multiplying by 1 and reducing the fraction. Then we've got for our numerator 6x plus the x subtract 35 didn't change. And then I did do 2 things at once here. I had the subtract, and then I had the 2 that is going to distribute, so I took them together at the same time. Negative 2 times x for subtract 2x, and the subtract 2 times the subtract 5 gives me a plus 10. Combining like terms, 6x plus x subtract 2x gave me 7x subtract 2x for 5x. Subtract 35 plus 10 gave me a subtract 25. All over the LCD, x times x subtract 5. At the 5 and 25, I saw I could factor out a 5, which left behind an x subtract 5. And then I see that I had a common factor that I could cancel out for my final result of 5 over x. Did you make it? It's a hard problem. It takes a bit of time. It's important to be careful, be tidy, and you're going to want to use a lot of paper.